Hey everybody, it's Taki117 back with Taki's Space Program. Here we have our Venera 1 probe. We're about 15 minutes from our maneuver node to head out to Venus, which is right over there. So we are going to go ahead and execute that node and time warp past the dark side. So already we've run into a little bit of a problem in that I don't have enough power to sustain myself on the dark side of the planet. But that's not an issue, because as soon as we come around the other side, our solar panels catch the rays of the sun, and we're good to go. Beautiful clouds. And it looks like we are over... Oh, we're coming up on Mexico. Awesome. There's the Yucatan Peninsula there, along with California on the west coast. Getting ready to fire up those engines. Now, what's going to happen is this burn is about 1100 meters a second. And once this burn is complete, I'm actually going to drop this stage for my interplanetary transfer. And that is, once I get to Venus, going to be what circularizes my orbit. So here we go, starting up our burn. Pushing our orbit out. You can see it slowly moving outwards, and then as we add more delta V to our rocket, as we expend more fuel, it will start moving faster and faster until eventually we reach escape velocity. Now I do want to make sure that I have my dish pointed in the correct direction, which I do. I am generating plenty of power to keep that active. There's the moon behind us. And there's Venus. Now, we will have to perform a mid-course correction somewhere between here and there, but that's not a big deal. That correction is probably only going to be a few meters a second of delta V. If it's more than 100, we've done something incredibly wrong. But even 100 still isn't a lot. So I've had to modify my plan just a little bit. Instead of sending my communication network first and then sending this, unfortunately my communication network doesn't generate enough power to keep keep the dishes on them active. So I've sort of just kind of abandoned that mission. I've left it in orbit of Earth just to have it around. I will probably end up deorbiting that eventually, and then redesigning that launch system if I do a multiple satellite launch at all. I might just do individual launches with this type of rocket. Still burning. This is a long burn, but considering where we're going, that makes sense. And as we can see, our orbit is already way out there. Still going. It's moving a lot faster now as we add more and more energy to our rocket. There we go, we've reached escape velocity, and now our orbit is moving out towards Venus. You can see it here, it's coming down towards the planet Venus as we add more and more delta V. There we go, we have an encounter. Venus periapsis is dropping to 1, and our burn is complete with a Venus periapsis of 10 million meters, or 10,000 kilometers. Now, of course, that's way too high for the 2 missions I'm trying to complete for this rocket. But it's not a problem. And there is that one. That one satellite. So now what I'm going to do is I'm actually going to warp this one until it reaches the Earth escape point, the point at which it leaves the sphere of influence of Earth, so that I can set up my maneuver node to adjust my orbit. Hopefully it doesn't do like this other one, where I will have to point things at it. So we are pointing prograde. The sun is over there, flying over Florida and Cape Canaveral again. So we're just gonna warp. That's all we're gonna do. So close that alarm because I don't need it. Warp to the sphere of influence. Now, of course, I don't have a connection because I'm out of range of all of my other satellites. So hopefully I can catch something. By the time I leave. If not, I can always go into the tracking station and point something there. Point something towards it. And there goes the moon, there's the Earth. We are well beyond both of them. We have just a couple minutes till we hit the sphere of influence. Here. About 9 hours. So I'll warp some more. Hopefully this goes off without a hitch and I have enough delta V to circularize. So we are coming up on Earth escape. Looks like I am losing power intermittently. And that is more than likely just because of the orientation of my spacecraft. It's not ideally oriented, so there should be some power fluctuations there. Oh, here we go. We are going to close that alarm. And we are less than a minute from sphere of influence changeover, or about a minute. Oh yeah, less than a minute. Now, I like to stop my warp very close to the SOI change. Now, I probably don't need to do that, but it really helps in that some strange things can happen when you change spheres of influence. There we go. We are now outside of Earth's gravity, Earth's influence. As you can see, our orbit has adjusted just a little bit. It's currently now at 14 20,000 kilometers instead of the 10,000 that was predicted to be at. But again, that's not a big deal. We want to find the closest approach, I believe, and we want to be within 200 kilometers. So, as you can see, I have a maneuver of 11 meters a second. That will adjust me down to, looks like 180 kilometers. Which, according to this, let's see. Network for Mars, network for Venus. Here we go. Okay, I need to be within 20,000 kilometers. So that's more than enough. And this particular craft is designed to complete both of these contracts. But I do have this interplanetary satellite also traveling to Venus, which is designed to provide communications once it gets there. If nothing else, I can... Let's see, this one does not have connection either. And this one I'm actually planning to aero capture, which is why it's still got this shell on it. Let's see where this dish is pointing. Still pointing at Earth. Okay, that's good. So it is likely that I either don't have anything pointed at them. There's 60 meters a second there. Okay, let's see how close this one is getting. Yes, it's infinitely likely that I just don't have anything pointed there. And this one's going to 87,000 meters, which is good. So my plan is to aero capture this one and then just adjust as necessary to give me that very nice communication coverage that I need for any incoming satellites. I can point their dishes at Venus. Or rather, I can point them at Earth, and then once they get close enough, I can bounce off of this interplanetary satellite at Venus and have a sort of relay setup. But for now, let's go ahead and ferry a space tourist into orbit. Now, space tourism contracts are some of the best contracts in the game, I think, because they essentially allow you almost free funds. Generally speaking, they are very neat and compact and very easy to accomplish. All you really have to do is take somebody, put them where they need to go, and then just come back. So let's see if I have something built already. Let's see. I have a Gemini Titan at the launch pad. Go ahead and launch him. We are going to remove both of those and instead add a pilot and my tourist. Now, the reason I need a pilot is because tourists don't do anything. You just sit in the capsule and they just kind of sit there and enjoy the view. Now, with pilots, they're the ones actually flying the spacecraft. So here we are on the launch pad. Beautiful day for a launch. We want to roll 0, full throttle, engage, turn that off. There we go. Engage our stability avoidance, or stability assistance rather, and launch in 5, 4, 3, 2, 1. Ignition and liftoff. Going to execute that, activating our smart assistance system. So things I'm looking for here, speed and altitude. As always, I want to start my gravity turn no higher than 1,000 meters and no faster than 100 meters a second indicated surface speed. 60. 70. 80, and I'm just going to go ahead and do it right about now. Just move 5 degrees off angle, it's really all you need. Just a little bit. Pitch down, and we're just going to make this a fairly smooth transition. Some goals I set up for myself, I want to be about 65 degrees by 5,000 kilometers. And then 45 degrees by 10 kilometers. Beautiful Cape Canaveral there. Southern-ish Florida. Now, you notice this rocket wants to pitch backwards. That's because this is effectively acting as a lifting body. And what that means is that the top of my rocket has more drag than the bottom of my rocket. And so what that causes my rocket to want to do is pitch up. Unfortunately, I don't want that because that's going to cause my rocket to flip backwards, which is going to prevent me from going into space. And 45 degrees by about 10 kilometers. We are on glide slope. I will eventually get the ascent guidance. I don't have it yet. I don't have enough science for it. Let's keep pitching down. Right about this time I can go surface velocity and just pitch minus 2 degrees for that, and that will keep me coming downwards. Actually, let's do minus 5 there. Let's see, perhaps this is 32 kilometers rising. My time is about a minute, which is right where I like it. Let's take a view inside, shall we? This is the view inside of our Gemini spacecraft. So we have our nav ball, we have a mission timer. Let's see, this is my vertical speed and radar altitude, which is already pegged, that is useless beyond, looks like about 3,000 meters. There is my nav ball. See my surface velocity, atmospheric density, all the fun stuff. There's my compass heading, a bunch of buttons, knobs, throttle, and my partner. And 100 kilometers. So now we're going to point orbit prograde. We are going to ditch our first stage there. Activate our RCS system to keep us pointed right where we need to be. And we are going to set up a maneuver node. So visualize that next step. Perhaps let's create that node, 500 meters a second. That is awesome. So we're now going to activate our engine. We need to turn our fuel cell on. And our fuel cell uses monopropellant. As you can see, my monopropellant is going down ever so slightly. but it's charging my electric charge. So now execute that node. And of course, because this craft doesn't have reaction wheels, I am limited to using RCS thrusters for attitude adjustment. So this is going to be a very short flight. Basically, it's going to be just enough to complete this contract. And 70 kilometers. There we go, so he is suborbital now. Now we need to get into orbit. Let's move this a little bit. So we have some space here. There we go. Adjusting ever so slightly. Let's turn the lights on. Yeah, there we go. Let's turn the lights on so those guys can see inside there. Let's do a it doesn't actually get me anything. Okay. So here we go. We're going to circularize our orbit. It'll take us 500 meters a second, which is infinitely more than this particular rocket has in it for its second stage. I'm mildly curious why the third stage says it doesn't have any delta V, but it's not an issue. We have more than enough. All we need is to get to orbit. We don't even need to complete an orbit, we just need to get there. Get our periapsis above the atmosphere. It should tick off this box. A little bit of roll here. There we go. There we go. So now the big part is I have to bring him home. So here's how we're going to do that. Let's... Ooh, looks like Central US is getting battered by a hurricane. So we are going to point retrograde. And we're probably going to end up coming down somewhere over here. That's our target landing zone. So I'm just going to fire up these engines. There we go. We're going to continue. We're actually going to point surface velocity negative, which is only slightly different than orbital velocity. Alright, so here we go. Ditch that stage. Let's see, we have plenty of electric charge, so we're going to go ahead and turn our fuel cell off. Come down just a little bit. Get our CS system, and now that we're in the atmosphere, we are going to ditch. Oop, there we go. We're going to ditch our service module. Let's see, this is set to deploy at yeah, I'm going to set it to deploy at altitude 5 kilometers. Right now, pre-deploy at we'll do 7 kilometers. 7 seems like a good number. And then the actual parachute. See if I can get to it here. to deploy at 2,500 kilometers. So here we go, we're coming down. Things are going to start heating up here soon. I'm going to turn my SAS off. Just save as much of that as I can. And start a little bit of a precession here, and that is simply because of the aerodynamics of the pod. It is wanting to point this heat shield towards the direction of travel, which in this case is retrograde. I'm starting to get a little warm. I do not have... Yeah, I don't have any sort of temperature indication here. We are coming down right where I wanted to. You can already see some lights there. It is unfortunately going to be evening by the time they make it down. But we're not on fire yet. That is good. You can already see things have started cooling off. Let's see, we're at 17 kilometers, so I can go ahead and get rid of that nose cone. Activate our parachutes so that they will deploy on their own. The reason I did that is so that if something happens to my pilots for whatever reason, they decide that they want to die or I run out of electric charge or something, those parachutes will still deploy and I can cover this command pod. So we're at 12 kilometers. Dropping well below supersonic speeds. You know, we're at less than 200 meters a second now. Dropping almost vertical, which is good. I'm probably deploy my drogue chute closer to probably 17 to 20 kilometers instead of 10. Okay. That's right, I have it set up for 7.5 or 7 kilometer deployment, which it really doesn't need. There that goes. See, we're already slowing down less than 100 meters a second, less than 90 meters a second now. At 5 kilometers, that will open. It should open fully. If it doesn't, there it goes. Looks like I could practically land on this drogue chute. So yeah, I will have to deploy that much higher up. Ooh, near crashing of things. Still falling slowly, passing through the cloud flare. $3,500 meters. 3 kilometers. Still falling. Ooh, there's our other chute. So now I can cut our drogue chute. Now we just fall on our regular chute. Now we are falling a little faster, but that's okay. 450 meters, okay. Still got a little ways to go. I'm a little worried. There it goes. Now we're slowing to a brisk 4.5 meters per second for the last 450 meters. Now, this altitude indicator is altitude from sea level, which means that we are actually less than that. Surface information. Oh, and we are down. There we go. Now we get to safely recover our vessel, and that completes our contract, giving us lots of money and lots of reputation. And hopefully getting our pilot Kerbal some experience. That's another reason I like doing those missions. It allows your Kerbals to do something easy for experience, because they get experience for flight, they get experience for orbit, and that should be enough to get them to at least 1 star. Now, of course, you didn't do an EVA, but that's... so we got a little bit of science for completing the contract, not a whole lot. We got some funds. Yeah. So there we go. There's that episode. Thanks for joining me. I'm Taki117, and remember, it's only rocket science.